Section 3.1, the Cartesian plane. Okay, that's a fancy term. It's just named after the guy who came up with this, Rene Descartes. Okay, so don't stress out about the name. Let's look at how simple it is to work with this. It's basically just number lines, okay? So we have a number line. We know how to do that, right? You have 0 in the middle. You have 1, 2, 3, and so on. -1, -2, and -3, right? That's our number line. We've dealt with that a lot. Well, let's say we decided to go ahead and throw a vertical number line in there as well. Okay, so now we have this vertical number line where going up is 1, 2, 3, and so on, and going down is -1, -2, and -3. Okay, this is what we're calling the Cartesian plane. It's our XY plane. It's called XY because we say this is the x-axis here, and we call this one the y-axis. Okay, so we have an x-axis, we have a y-axis. These are just two number lines, okay? Now, the number lines, because we took two axes and we put them perpendicular to each other, we've created ourselves these four quadrants, okay, these four quadrants. In other words, we can label this as quadrant number 1. Here we'll have quadrant 2. Notice we're going counterclockwise. Here's quadrant 3 and quadrant 4. So you can describe the location of something by saying what quadrant it's in. It's not the most accurate way to describe something, but it is a way that you can describe its location. So here's our x-axis, here's our y-axis, or you can describe a quadrant. Let's say we want it to be more precise though. Okay. So maybe instead of describing it as quadrants, we want to say it's, where x is 2 and y is 1. So that's about right here, right? Well, that's where we're going to get into what these things called ordered pairs are. Okay, so an ordered pair is exactly what it sounds like. It's an ordered pair of numbers. An x value followed by a y value. The x value tells you where you're located horizontally, where the y value tells you where you're located vertically. When you put those two together, it tells you where exactly you are in the plane. Okay, and so x is always listed first, then y. So let's do these couple of problems real quick. Let's plot these points. So -3, -2. Okay, well, here is our middle, so -3 is 1, 2, 3. And then -2 is down, so 1, 2. So where does -3 and -2 meet up? Right here. So that's in quadrant 3. So we could say that that point is located in quadrant 3, and this is exactly where it's located. Okay, what about 5, 1? So 5 is our x value, 1 is our y value. So on the x, we're going to go 1, 2, 3, 4, 5. And then on the y-axis, we're going to go up 1. That's going to be right here. And if I were to ask you what quadrant is that located in, you would say that's in quadrant 1. Okay, these aren't difficult, right? 0, -3 is a little trickier to answer, but let's talk about that one. 0, -3. So x value is 0, which means that's right here, right? That's right in the middle of the x-axis. And then -3 is y, so we're going to go down 3 spaces. 1, 2, 3. And there is our point there. So we couldn't say that's in any particular quadrant, but we can say that it's located on the negative y-axis. That's an easy way to describe its location. Okay, 0, -3, located on the negative y-axis. Okay, and then finally -5, 2. So -5 along the x, 1, 2, 3, 4, 5. +2 for y, so up 2. That's going to be here. That's where those two meet. That's in the second quadrant, quadrant 2. Okay, so an ordered pair can describe a point in space, right? A point at least in two-dimensional space along the xy plane. Let's talk about some other ideas. So here we go, midpoint, distance, and slope. Okay, so this is just if you have a pair of numbers, a pair of ordered pairs, I should say. A pair of ordered pairs, how about that? If you have a pair of ordered pairs or a pair of points, you can look for the midpoint, the point between them, the distance between those 2 points, how far apart they are, and the slope, the measure of how steep a line is if you're going from one to the other. Okay, so we'll look at all that in just a second. So midpoint, the midpoint formula just says you have a new ordered pair here. The x value, your new x value, is just the average of the two x's. You add them together and divide by 2. The new y value is the average of the y values. You add them together and divide by 2. Okay, that gives you a new point, the midpoint. Okay, distance, this one looks the most complicated. It's really not that bad. Okay, here you're going to subtract the x values and square it, subtract the y values and square it, add those two together, then find the square root. Okay, so it is kind of a lot going on there, but each step by itself is not too difficult. Okay, that will give you how far apart the 2 points are. And then finally there's the slope. How steep of a line would it be to connect them? All right, if you drew a line that connected them, how steep is that line? You subtract the y values, you subtract the x values, and you put the difference in y over the difference in x. All right, that's talking about the formulas in abstract. Let's actually do some problems here. So let's go ahead and find the midpoint, the distance between them, and the slope of these 2 points. Okay, notice I didn't graph them. I didn't put them on a graph, but I do want to just use the formulas, okay? So to find the midpoint, remember the midpoint formula. Add the x's together, divide by 2, add the y's together, and divide by 2. Okay? So we'll be very careful here. Let's label our numbers. Here we have an x and a y, and here we have an x and a y. Now to differentiate which ones are which, I'll go ahead and put little 1's for the first pair and little 2's for the second pair. Okay, it doesn't actually matter. If I would have made these the 2's and these the 1's, that would have been fine as well, as long as I kept the 1's and the 2's together. Okay, so let's put it together. Put a plus, divided by 2, comma, plus, divided by 2. Let's fill them in. So x1 is negative 5, x2 is negative 1, y1 is negative 4, y2 is positive 2. I want to be careful with my double signs here. Anytime you add a negative, you're really just subtracting it. So negative 5 minus 1, that's negative 6 over 2. And negative 4 plus 2 is negative 2 over 2. Now let's simplify each of those. Negative 6 over 2 is negative 3. And negative 2 over 2 is negative 1. So there is our midpoint. That's the point right between those other 2 points. Okay, let's find the distance now. Remember the distance formula. We want the square root of the difference in the x values squared plus the difference in the y values squared. The square root of all of that. Okay, well, I'm going to use the same 2 points. Okay, so x2 is negative 1 minus x1 is negative 5. Okay, going to close that, square it, plus y2 is 2 minus y1, negative 4. Close that up and square it. Okay. Let's be careful with our double signs here. When you subtract a negative, you're really adding. Subtract a negative is adding, so this is really negative 1 plus 5, which is 4, squared, plus 2 plus 4 is 6, squared. 4 squared is 16. 6 squared is 36. 16 plus 36 is 52. Okay, we talked about breaking down the square root of 52, or breaking down a square root in general. 52 is 2 times 26. 26 is 2 times 13. So I have a pair of 2's. So 2 comes out. 13 is left inside. Okay, this is my exact solution. Okay, this is the exact solution. Now, if I wanted to find an approximated solution, right, the approximate value, I would type this in the calculator, 2 times the square root of 13, or just the square root of 52. Okay, so let's see, the square root of 52 is 7.21. So I would say that is my approximated value. Okay, I did round it. Okay, it's 7.211102551, and it goes on forever. Okay, remember, it's an irrational number. So there's no end to those decimals, and there's no repeated patterns or anything like that. So we have to decide where we're going to round it. I decided to round to 2 decimal places. But the fact that I rounded it is why it's an approximate answer. Okay, this 2 squared root of 13 is the exact answer. Okay, finally, let's find the slope. Now remember, the slope, subtract the y values, find the difference in the y values, find the difference in the x values, and find the ratio between the differences. Okay, so fine, y2 is 2, y1 is negative 4, x2 is negative 1, x1 is negative 5. Let's take care of our double signs here. That's a plus. That's a plus, so that's really just 2 plus 4, which would be 6. Negative 1 plus 5 is 4. Can I simplify that? Yes, they're both divisible by 2. That will give me 3 over 2. So there we go. Midpoint, distance, and slope between the 2 points. Okay, and so that is the end of this section. That's the end of section 3.1.